Well, hello, everyone. Good morning, good evening, good afternoon. On behalf of the American Membrane Technology Association and Torre Membrane USA, I'd like to welcome you all to today's webinar, UF/MF Module Selection Flexibility, a decade after the introduction of the Universal Rack. My name is Ben Freeman. I'll be moderating the webinar today. I started my career with MEMCOR about almost 20 years ago and worked for them as a field engineer. And then after that, I worked for Hydronautics, looking after their UF and NBR technologies for about 10 years. Then I moved to a company called MEMStar, where I was also looking after the UF and NBR technology team. And a little over 2 years ago, I joined with Torre. And now with Torre, I'm the product manager for their UF and NBR technologies. And I'm happy to be able to lead this discussion today. Today's webinar is the first in a two-part series. It's going to be hosted by AMTA and Torre. We have some wonderful guests that will be joining us today. I'll talk more about them a little bit later. Today we'll have an initial 30-minute presentation by myself, and then we'll have 3 presentations from OEMs from our industry, and then we'll have about 15 minutes for Q&A at the end. So please, we'll go over those questions and answers at the end of the presentations, but you can send them in at any time. So a couple housekeeping items before we get into the first presentation. First of all, everyone is muted at the moment. If you would like to switch your audio from your computer to your phone, you can use the control panel located in the upper right corner of your screen. You just select telephone in the audio panel, and the dial-in information will be displayed. As I just mentioned, you will have the opportunity to submit text questions at any time during the presentations. You select questions from the drop-down menu towards the bottom of the control panel, and questions will be collected and addressed during the Q&A session at the end of the webinar. You may download today's presentation by clicking Handouts in the control panel and saving the PDF file to your computer. We will also have polling questions throughout the presentations. Please note that participation in these polls is necessary for you to receive your continuing education credit in some states. Regardless of your state agency, we strongly recommend you to respond to all polls and surveys to demonstrate participation. And at the end of today's event, we encourage you to please take our survey. We hope that you will engage with us today and give us your feedback. And with that, we can go ahead and get started with the first presentation. So, as I said, the name of this webinar is UF and MF Module Selection Flexibility, a decade after the introduction of the Universal Rack. It came up with that title from my feeling that it had been around the decade that we had been talking about and doing these open platform or universal racks. However, reality is that they've been around a lot longer than that. So today, what I'd like to do is go through some of the history of how we got there. But really one of the main purposes is to show that these universal or open platform systems are not new anymore. At this point, they have become commonplace, and for some good reasons, which we'll go over today. Second purpose of today's webinar is to present some options for replacing legacy UF or MF products. So if you have a system using proprietary modules, you now have options to replace with other manufacturers' technologies. And lastly, and I'd say most importantly, we've invited suppliers of open platform systems to join today and to share their experience over the past 10 or so years supplying these systems and some of the best practices that they've been able to develop over that time. Next slide, please. So as I touched on briefly earlier, I'm going to start the presentations today, and I'll be covering the first two items listed on the agenda. So I'm going to give a very brief history of UF and MF system supply, and then sort of explain how and why we went from a market that was dominated by proprietary systems to one that is now mostly calling for open platform systems. Then I'll go over options for replacing legacy products. I was searching for the right word there. By legacy, I mean old, but legacy sounded a bit nicer. So in any case, these are modules that have reached the end of their life and need to be replaced. After that, we'll have presentations from the top OEMs that are offering open platform systems. First will be Richard and Aaron from Bywater. Then we'll have Denis from H2O. And lastly, we have Dan from Westech. And if you don't know these guys, they are leaders in our industry. They bring a ton of knowledge and experience to this discussion. Their views on this topic are as valuable as any. I'm extremely grateful for their willingness to participate. They've all put in a lot of time and effort into their part of this webinar. So I really appreciate that. It's also notable that they are each other's biggest competition. And on top of that, we even have an Englishman and a Frenchman participating. So, however, we know that they're gentlemen, so I'm expecting that everyone's going to play nice. And finally, we'll have a Q&A session at the end, as we discussed before. Next slide, please. So before we get started, I think that there's a few terms that we're going to be using quite a bit. I've already used several of them, but I think that it's good for us to make sure that we're all on the same page with these terms. Our industry is great at creating acronyms and terminology, but not so great everybody using the same acronyms or terminology. So for the purposes of today's webinar, when I say proprietary system, I'm talking about a membrane filtration system which is designed for one type of module and operating process. And more specifically, what I'm really referring to is vertically integrated companies that were not just supplying the membrane modules, but actually own that technology. And those, some examples are basically Memcor and Xenon. Also Paul, even though they don't actually manufacture the module, they had an exclusive arrangement to supply their MF module for quite some time. Next up is the open platform system. So I'm using OPS, a whole lot through the presentation just because it's easier to write. These are systems which can accommodate more than one type of module and operating process, although in the term universal is rarely accurate in what systems are actually delivered. And what I mean by that is these systems that are supplied don't typically have the capability to operate every single type of UF or MF module that's available on the market. We'll talk about that a little bit more later. And then we have original equipment manufacturer, or OEM. These are the suppliers of the membrane filtration system, also known as system integrators, and that's the guys that are on the phone, companies like Bywater, H2O Innovation, and Westech. Next slide, please. So let's have a quick look at some of the history of UF and MF. So way back in 1973, Ramacan, owned by Coke, was the first to introduce a hollow fiber capillary membrane system. And in the 80s, UF and MF products were mainly used in industrial applications. Then around the mid to late 80s, you had companies like Mimcor and Aquasource as the first that were really starting to explore drinking water applications. And then starting in the 90s, we saw Xenon and Paul join the game. And with Xenon, they brought the first submerged system, which we won't be discussing today. This is all about pressurized UF. So then when we jump into the 2000s, you can see on the graph on the right, you can see the blue bars. That's representing the installed capacity of UF and MF in the US. You can see that in the 2000s, it really starts taking off. The growth rate was pretty impressive. And we also at the same time had a large number of UF and MF product offerings that were introduced at that time. And I guess that there's probably a lot of reasons that happened, but I would say that in large part the long-term to enhanced surface water treatment rule was a major contributor, and UF MF membranes, with their ability to provide over 4 log rejection of crypto and giardia, they serve that well. And also there were around in the 90s and maybe a little bit after that, there were some instances where there were some outbreaks of pathogens in the drinking water supply. So there was public attention on how to handle that issue. UF and MF hollow fiber products are a good solution for that. Also, that they can be integrity tested to verify that they're doing what they're supposed to be doing. So, and then lastly, as we moved into the 2000s, there was a lot of, or I should say 90s and 2000s, there was a lot of rapid product development and increases in manufacturing capacity. So the cost of the products went down significantly. All those factors came together with others, I'm sure, to lead to a rapid expansion of UF and MF in North America. And then the last point on this slide is that from a report in 2000 that was issued in 2013, which was from the city of San Diego, when they were looking at their advanced water purification facility, they noted that at that time, 3 manufacturers currently supply approximately 90% of municipal filtration systems in the U.S., including Siemens Memcor, Paul Corporation, and GE Xenon. So at that moment in 2013, the market was absolutely dominated by those 3. So next slide, please. So I guess the question is, how did that happen? And I would say, again, that there's I'm sure a lot of reasons for it, but in my mind, I think that when there's a new technology that's been introduced, there are certain risks that need to be mitigated, and a lot of those could be mitigated by these vertically integrated proprietary system suppliers. So early adopters of new technology are going to have a lot of legitimate questions. For instance, who is financially responsible, or more than financially responsible? Who is responsible, period, in case the system fails? Well, it's nice if you can turn to one company to get those sorts of answers. These were generally larger companies that could provide the financial backing that was needed. Also, there was a lot of question about how can I know that this is going to work, and how well is it going to work, and how should it be designed? And a lot of those questions called for pilot testing. So I mentioned that I started my career with Memcor, which was then owned by Siemens, and my entire job was to run pilot tests. So there were some instances where I was managing 6 pilot tests at the same time, and I think I was one of 5 or 6 engineers that Memcor had doing the same job. So that'll give you an idea of the scope of pilot testing that was happening around this period. Then you also need somebody who can provide the proper engineering, and you need someone who you can call in case there's a problem after sales. So these companies were able to provide a lot of that, and I'd say those are some of the big reasons that they were so dominant early on. Next slide, please. However, there are some challenges, of course. The first one, and I guess kind of the driver is of these other issues, is that end users get locked into one membrane manufacturer, and so that can lead to a variety of challenges. For instance, when there are some performance problems, you're limited to resolve those problems with the limits of the product that you're using or the operating process that you're using. Then you have a limited capability to take advantage of product and process improvements. For example, when people come out with higher surface area modules, or maybe materials which have a greater chemical tolerance, or are stronger, whatever the case may be. If you're locked into one module type or module configuration, then you have a challenge of trying to take advantage of those improvements. Also, if you can only use one type of product then from one manufacturer, then that essentially eliminates competition. And I've noted that it decreases competition and used to eliminate. So like I said, there are now some options for replacements even on these systems, but there were not before. And then the last one here is that there's always a long-term supply risk. So what happens if a manufacturer goes bankrupt or decides that they're just going to stop making a particular product, then what are you supposed to do? So these are some of the difficulties that we're facing in proprietary systems. Next slide, please. So now let's shift gears a bit and talk about the introduction of the open platform system. So as I noted a couple times that these have been around actually quite a bit longer than 10 years. So you can see on the left side of the screen there, I guess what you would say is the first open platform system dates all the way back to 2004 with the Two Rivers water treatment plant in Wisconsin that was designed by Carollo. And that one originally installed with hydrocapped membranes and then was replaced in 2016 with ingot membranes. So interesting to see that we have an example that far back. But at the time, I would say that the number of technologies that were out there and that were proven was limited. So didn't see many of those types of systems. However, starting around, I noted 2011, maybe a little before, there started to be more and more demand from our industry. People were looking at the U.S. MF market and comparing to the RO market and realizing that some sort of standardization would be beneficial, certainly. And then, so we had the demand around that period. And then in 2015, the Clifton water treatment plant was started into operation. That was another one designed by Carollo and supplied by H2O. In the same year, SPI was leading the pilot program at West Basin, where they were looking at quite a variety of different membrane technologies. And then in 2017, we've got another instance of an open platform system with the Lakeshore water treatment plant done by, at the time, CH2M, now Jacobs. And let's then jump forward, if you can click the slide for me once. Jump forward to today, and now we have somewhere around 70 to 80% of project specifications calling for open platform systems. So quite a change from 2013. So then let's ask ourselves what caused that shift. Well, for one, the engineering firms played a major role. So I indicated that on the previous slide, talking about people like Carollo and SPI and Jacobs. Certainly the others contributed as well, but starting around that 2010, 11, 12, 13 period, we started to see the engineers figuring out how to take advantage of, how to design for these open platform systems, and then how to start building specifications around them. So engineering firms were a very strong force in this whole thing. If you go back and look at presentations that were delivered in our industry conferences around this period, you'll find a lot of material on the topic. We also had a desire from the end user. Then the next one I'd say is that there was a general acceptance of UF and MF technology. Remember that the very first one came out in '73, but even well into the 90s, the installed capacity of UF and MF was fairly small, but by the 2000s, it was even surpassing some of the RO installed capacity, and then also a lot more products came onto the market. Were certified for drinking water application, and we also had a large increase in the offerings from the OEMs. There were, if you could click the slide, please. There were unfortunately also some bad experience that end users had, and those included performance issues such as irreversible flow loss and fiber breakage. There was some mechanical failure of different module parts, and there was some instances where end users were being charged really, really high prices for replacement products. Now, not my intention in this presentation to talk negatively about any company or anyone, and I would say that the number of bad experiences was on the whole very, very low percentage. But as we all know, nobody talks about the good stuff; they only talk about the bad stuff. So those negative experiences did stick out in a lot of people's minds and were a driver for this shift towards the open platform system. Next slide, please. That said, there was that period between, if you go all the way back to say 2004, all the way to what I think really around 2015 would be when we saw, when we started to see the very rapid growth of the open platform system. So the question is why? And I think that there's several things that came up. Number one is there are certainly technology differences between the UF and MF products that are out there. Around that time, there was some question about the experience of the OEMs that were offering open platform systems. Also, what about the warranty management? Now if you have a company A that's providing the membrane module and company B that's supplying the system, is that going to create some warranty concerns? All right. And then lastly here would be, what about regulatory issues? Is it going to be more difficult to get these systems approved by the regulators? Could you click once for me, please? Well, in terms of warranty, turns out that really the open platform system arrangement is no different than how warranties are managed in the RO world. So that really not caused any issues whatsoever. We can get into some of the questions about that if people have them later on, but in a nutshell, there's no problem to manage a warranty, even though one company is providing the membrane module and another is building the system. And then with the regulatory issues, we haven't seen any major problems there, and in fact, the OEMs that are on the line have figured out clever ways to make just minor changes in some of the inputs in the controls or on the screen to go from one module to another module type. So really no problem there. Okay, next. But let's talk a little bit more about the technology differences. So as you can see here, there's a lot of different pressurized UF and MF modules out there. You have For starters, you have some that are operated from outside in, you have some that are operated inside out. You can see that almost all of these are different shapes and sizes, ranging from 6-inch in diameter all the way to 10-inch, and from 60 inches tall to 85. Then on top of that, you have different port configurations. So some have a feed which enters at the bottom center. Some have one that comes in through the bottom side. Then you have the same sorts of differences on the filtrate port, being from the top center at the top side, and the backwash waste or air vent, same thing, top center or top side. And then in addition to that, you've got port sizes ranging from 1 1/4 inch all the way up to 3-inch, and then those port connections, some of them are grooved in, most of them are grooved in, but some are also threaded, and sometimes those are unique types of threads as well. So there does appear to be a challenge to come up with a system that can accommodate all of these differences. Next slide, please. In addition to that, when we take a look at the characteristics and the operating limitations of these different types of technologies, you find even more differences. All right. So I've listed 7 different modules there. This is not all of them, right? We had a lot more on the previous screen, but you can see that we've got different materials. Within those materials, you have different types of manufacturing methods. I already noted that there's different operating modes. There's also pore size range from 0.01 micron to 0.1 micron. I apologize. There's an error on the table there. That should be micron, not millimeter. And then you've got differences in the cleaning pH range, as well as chlorine tolerance, and also a big range on the surface area from, in these examples here, from 538 square feet up to 1,130 square feet. So again, there are certainly differences that don't make it obvious necessarily that you'd be able to come up with a system to accommodate all these technologies. Next slide, please. So how do we handle that? Well, basically, you need to narrow the field. Typically to 3 or maybe 4 different types of similar products, as I noted in many instances here. So, as an example, and as we commonly see, we'll find a lot of these systems are really better suited for treating modules that all operate from outside in, all using the same material, PVDF, which means that chemical tolerances are going to be pretty close from one module to the next. And then if you can choose modules with similar surface areas, then you can reduce the number of spots that would be needed to accommodate all the different surface areas. And then you want to operate around the same pressure, filtration pressure, as well as have a similar type of backwash process and flux. So on the previous slide, some of those technologies only use backwash with no air scour. Most of them do use a backwash with air scour. So choosing technologies with similar backwash procedures and backwash flux, as well as similar port configuration. All of these things make it a lot easier to design a system that can accommodate more than one. Next slide, please. So another one of those initial concerns was that there were not a lot of product offerings or experience delivering these sorts of systems. So back in, I think it was 2010, maybe 2011, Suez Degermont introduced the first quote-unquote universal system, which is called the smart rack. And then if we look at the products that are out there today, you can click once. Now we have a lot more options, all right? So we have with us today people, we have H2O, Westech and Bywater. Wigan also has an open platform system as well as Harn. So nowadays there's a lot more products that are out there. And let's go to the next slide, please. So it's not just that the products are there, but the experience and the scale of the systems being delivered has grown tremendously since 10 or so years ago. On the left side of this slide, you can see a table that was provided by Denis at a conference back in 2016. And at that time, he's highlighting a good number of projects actually that were built or designed with an open platform system. But you'll notice that back then, there's a lot of these that are 1 MGD or less. I guess then a bigger chunk if you expand that up to say 5 MGD. Not so many larger than that. Okay, larger than let's say 10 MGD. So now the table on the right, you can see that the size of these open platform systems has gone all the way up to 40 MGD. And these are just a few, right? So I'm just pulling kind of the big ones. On top of this, there's lots and lots of smaller ones that have been supplied by those OEMs on the previous slide and on the phone with us today. So these concerns over the offerings and the how well those open platform systems have been refined. Now the OEMs have had time to do that, and so we're in a much different place than we were about 10 years ago. Okay, so at this point, I think we're going to have our first poll question, and it's from me, so I should know it. Okay, so the first poll question is, when did the first open platform system start operation? Was it 2016, 2015, 2004, 2017? I'll give you a bit of time to answer. Okay, so if you haven't had a chance to submit yet, please go ahead and do that. All right, so it's a bit of a trick question, I have to admit, okay? Because the system that was supplied back in 2004, it was interchangeable, and we were able to use 2 different types of modules. So according to the definition at the beginning of this presentation, we would say that the system supplied at 2 Rivers was the first. However, I would also accept 2015 because that was the year that the Clifton water treatment plant started operating, and that system was designed with even more capability to accommodate more modules, and so good job, everyone. I'd say both are correct. Okay, and then let's do another poll question now. Okay, in 2024, approximately what percentage of specifications call for open platform systems? Is it 20 to 30%, 40 to 50%, 50 to 60%, or 70 to 80%? Give you a moment to answer that. Okay, if you haven't done so, please submit your answer, and we'll close it and see. Very good. That's right. So it's in the range of 70 to 80%, maybe even a bit higher, but that's about what I could collect from talking to different industry experts. So this is I think a strong illustration of how much the open platform system is taken over in our market. Okay, very good. Thank you. Okay, so I'm gonna go through now. I'm gonna wrap up this section on the open platform system, and then talk a little bit about replacing those legacy products before we move on to the next presentation. So this part here is supposed to be some of the lessons or observations that we can apply to our current market. So the first one that I pointed out is that the concerns about module price and lead time variability have been realized. We had a major increase in demand for lithium-ion batteries, which use PVDF, and along with challenges related to COVID, those things led to over a 40% increase in the price of PVDF in 2021. You can see in the graph on the right there, that is the price of something called R142B, which is a precursor to PVDF. Over a 6 or 7 month period, we saw a 4x increase in the price of that chemical, and that led to this. Was part of the reason that it led to this tremendous increase in the price of PVDF. And of course, PVDF, since that's what the membrane is made of, when that raw material increases in such a major way, then the cost of the module is certain to increase in a major way as well. At the same time, since the lithium-ion EV battery market exploded around that time, a lot of the manufacturers' capacity was reallocated to those manufacturers. That market is much more profitable and attractive for PVDF manufacturers. So we saw a large decrease in the amount of PVDF that could be supplied for membrane manufacturing, and that led to, in some cases, lead times of over a year. So this is a good example of why it's nice to have more than one option. I should note that the numbers that are provided here are given from a Toray perspective, so it was not necessarily the case for all manufacturers that they experienced this type of price increase. In fact, I think a lot of them saw larger increases, and each manufacturer also handled the supply issue differently. Some of them were able to provide modules to secure their supply of PVDF and to supply modules in much shorter amount of time, and some were experiencing those lead times greater than 1 year. So if you had an open platform system during that time and you were up for replacement, it would have been very nice to have multiple options for that replacement. Next. So we've also seen that products come and go. So this was the slide from before. Let's give it another click. So let's not say that this is exactly the case, but let's say that products come and go. And so when that happens, we need those options. Okay, let's go to the next, please. We've also seen some I guess, standardization of the types of language that we see from the engineering firms. Often we're seeing about three modules being included and getting some sort of language like is shown here. So the membrane filtration system, including the rack, backwash pumps, blowers, air scour, compressed air, CIP system, control systems shall be designed to accommodate modules from the following list. And we often find that is 3 modules, and those 3 are often based on pilot testing. So pilot testing is still beneficial, but not being done quite on the same scale as it was before, and usually being led by the engineering firms these days. And we also, as I noted previously, now we have a lot of significant OEMs that have grown their experience, but the companies are also much larger than they were about 10 years ago. So that speaks to the point of companies that are capable to give that financial backing and that have the capability to the engineering resources and the after sales support team. All of those things can now be well covered by the OEMs that we've been talking about. And then we all know that we want to talk to regulators early, make sure that everyone's on board. That is for new systems, as well as when it comes time for any sort of replacements. If you're looking at switching from one technology to another, we need those regulators on board as soon as possible. Okay, so lastly, let's talk about some of these solutions for aging proprietary systems. So like I said, now there's multiple options out there. I'm showing some examples here. So what we can see is that there's more than one, up to 4+ in some instances for different types of technologies. So if you have one of these proprietary systems, you are not necessarily locked in like you were before. Okay, next slide. And you might have a number of reasons for changing. So there may be improvements in the fiber or module technology. Maybe you need to increase the installed surface area so that you can increase your capacity, or maybe you want to reduce the flux. Of course, when we have more than one product available, then that's going to create price competition. You have more ability to address performance issues. Maybe the relationship has gone sour and you want to do business with somebody else. That's now an option. And then lastly, products do eventually get discontinued. So you need to have some ability to change to another module. That was the case of the picture on the right there. The product had been discontinued, no longer available, so they needed to find another Okay, next please. And on the on the direct replacement side of things, so again, we need to address the LRV, log removal calculations, and that might require a little bit of reprogramming, something to be aware of. Of course, it's not a good idea to mix two different types of modules, old and new, on one train. And even when you are doing a replacement, let's say that you have 5 or 6 trains, mixing the model within from train to train can introduce some challenges that people should be aware of. So you need to keep in mind that you may need service on both the old and the new, and warranty is also a consideration, making sure that your warranty is not impacted, those sorts of things. So generally speaking, so far it seems that it's easier to replace everything instead of going train by train, do all the modules basically at one time. Not to say that you can't handle it the other way, but it does bring a few more challenges. And then we've also seen that in most cases, the equipment that's been provided is actually large enough to handle some differences in operating pressures and flow rates. And then lastly, again, let's talk to the regulators as soon as we can, get them on board and take care of any concerns they may have. And so, as a summary here, we've seen the benefits of the open platform system over the past 10 years, pretty much as we thought that we would. They mitigate module supply risk, they allow for technological advancements, they give you options for resolving problems, and they create good price competition, not just at the new builds, but also at module replacement time. So as a result, if you could give me one more click, I would say that really this is the new normal, and I expect that things will continue this way in the future. And then one more click for me. When it comes to the direct replacements, takeaway there is essentially that there are options now, and those options can bring technology improvements and address a variety of problems, fouling, fiber breakage, capacity constraints, etc. So with that, that'll wrap up my presentation. Now we can move on to better things. So first up, we have Richard White and Aaron O'Donnell from Bywater. Richard oversees Bywater Group's membrane treatment, desalination, and water reuse projects globally. He's worked in membrane treatment for over 18 years and has become a world leader in membrane treatment system process design, project implementation, commissioning, and training. As the president of Bywater Inc., Mr. White spearheads key strategy and technology shifts across the industry, incorporating some of the latest advancements in process technology and improvement. We also have Aaron. Aaron has 27 years of successfully delivering water and wastewater projects internationally. He brings a wealth of experience to his role of VP of Bywater. Mr. O'Donnell is responsible for operations and oversees the development and delivery of the group's leading-edge desalination and water reuse contracts, ensuring the continued success and growth of the business in the UF and RO membrane space. All right. Thank you, gentlemen.
Thank you, Ben. Good morning, good afternoon, good evening to everybody. Thank you for being here. The poll questions are scattered throughout the presentation. I ask that I not know where they are, just to create a bit of suspense for everyone, including myself. Keep you on your toes. So to go through, I don't want to repeat too much of what Ben has already been through, but we learned early on when we were tackling this market and recognizing that the open platform is sort of the direction in which the industry is going. And because of the need and the engineering consultants, the owners wanting to reduce that risk and to provide maximum flexibility for the lifetime of the plant, it's necessary, I think, to have that kind of open platform. And there's been many iterations over time as we've started to design and build these, a lot of lessons learned. And you can make an open platform rack, train, accommodate as many modules as you like. But as you say, there's Ben mentioned there's a lot of outliers. Some membranes, some modules will require a much higher backwash rate, a much higher air scour, and so you're then designing all the ancillary equipment to be much larger unnecessarily, and you want to try and keep the system and the capital cost as tight as possible. So you want to try and narrow that down to those that are quite similar as far as performance and size, the similar dimensions, and currently our most compact open platform design, smallest footprint, as well as the ancillary equipment, can accommodate up to 5 different modules, maybe more in a few cases. So we've been pretty successful in that, and with the other OEMs on here, we've all learned a lot together in the industry, and pushing the envelope in trying to make these better and more efficient, more flexible, and reducing the risk. And Torre's been a good partner on many of the projects as well. Sorry, went too far on that. There's a delay. Go back one. So we all know where the poll question's coming. So what's important and what we've learned, there's a few manufacturers that have the proprietary systems. They have what some call like a butterfly design, where you have a center feed, kind of a valve nest in the middle of the unit, and then there's modules and racks either side. The good part about that is that it allows for quicker draining, quicker fill times, and more balanced flow between all the modules. Instead of having the valve nest or valve rack on one end and then a really long module rack, you can get dead zones, especially at the furthest end. You've got typically a lot less flow through those than at the front. And so to mitigate having to put some valving and other methods to try and balance the flows out on particular modules or sections of the train, there's this center feed kind of design that we've incorporated on some jobs. And then our newest approach is to have the best of both, where we've got the valve nest on one end, which is good for configuration of all the header and feed piping in the plant. So it could be along one wall or one side of a building instead of the middle of the plant. That can be very difficult when you're having to jump across to the CIP systems and everything else. The center feed can be quite tricky. So the valve nest being on one end is good, but then our newest kind of concept for the open platform has this center feed, which I'll show on the next slide, which kind of has a win-win in both cases. We'll get onto that after the poll question. So back to Ben on that.
There's a bit of a spoiler there. So here we have the first poll question, which is UF modules rated for higher operating pressures can be most useful for treating a feed stream with high TSS, direct coupled UF RO systems, when the design engineer is creating a lot of stress, or for removal of total organic carbon. Okay, so take a moment, please. Please make your pick. Okay, let's go to the result. Nobody picked number 3. That was mine. Yeah, you are correct here. That is, well, I don't know if Richard, do you want to speak to that one? It's your question.
Yeah, it's for the direct feed. If you're feeding directly into an RO system or some other system downstream without the brake tank, you're obviously, instead of going into an atmospheric tank or little to no pressure on the filtrate side of the modules, you're going into a pressurized header, normally giving a few bar or 30 to 40 psi of suction to, say, feed pumps to the RO, high pressure pumps. You're needing the UF modules to be rated for the filtrate pressure plus the maximum TMP, transmembrane pressure, across the module. So yeah, that it lends itself where you've got that direct feed. You need to make sure that the system and the modules can be rated for that application. I know there's multiple module manufacturers, including Toray, that can do that. So we've done many of those direct feeds, and we'll get onto some examples for our open platform. Okay, so going back to kind of the new approach for our open platform train that we've got available is to create this balanced flow between the modules, both from when it's operating. You've got lower pressure drops across all modules, and then when you're backwashing and when you're CIPing or chemically enhanced backwashing, you've got that even spread of velocities and flow rates through those individual modules throughout the entire skid. So our header arrangement, you've got kind of feeding in the middle of it, and then they split and take off at the ends, and so you're feeding from one side of it and taking off the other in a Z-shaped pattern, similar to what we would employ on an RO system with RO vessels, where you're making sure you've got even balances, or even if it's PX, pressure exchanger units on a seawater system, it's the same concept where you're wanting to really optimize efficiency and good header design, and it also is quite compact the way we've designed it. So that's a new offering that we provide on our open platforms. It's smallest footprint as well. So it's our next generation. Happy to discuss. We've also got a lot of other innovations with that design that we're happy to go through. Anyone who has questions on that. On an experience that we had prior to this new development, we did incorporate the butterfly center feed design. So instead of, again, having those long modules racks, we've split it in half and had them on either side. You can see there in the photo. This is a project in California for close to 15 million gallons per day. We've got 10 trains of 80 modules. There's 40 modules each side, and we've got all the feed piping in the middle, coming from underneath and on top. And then this train, these trains actually feed directly into a 95% high recovery RO system without any breaks in the system. And we also are feeding a recovery UF. So all the backwash waste from the primary system goes to another open platform racks that isn't rated as higher pressure because it's not direct feeding. And I'll show on the next slide the process flow. Oh, see, there's a polling question. So Ben, over to you again.
Okay, let's go to the next one. So here we have, when evaluating performance of a UF membrane, is it more important to know the filtration rate in gallons per minute or flux in gallons per square foot per day? Please select one of the following. Need some Jeopardy music in these moments. Okay, if you haven't submitted, please go ahead. Ah, very good. Yep, that's correct. Okay, Richard, if you want to comment, you're welcome to.
Great. Yeah, that was somewhat of an easy one, self-explanatory. Hopefully, everyone knows the GFDs of the international folks, the LMH or liters per minute or whatever you use. I'll take back over the slides. Yeah, it's obviously a flow rate in the system is irrelevant as far as performance unless you know how much square footage of membrane is installed. So you can see how much flow is going through that proportion of surface area, and then you can track that line in the sand, that flow rate and performance, or TMPs and everything else. So same with RO and any other membrane application or filtration in general. So this is the project we had in California, the 15 MGD. It's actually a 93% recovery system overall. It's a water reuse application. And so for this open platform and our primary UF, we called it, you can see at the top there, feeding directly into the primary RO. The secondary RO was basically the third stage where we had redundant third stage RO trains. And so we can still keep the capacity of the train plant up by having the primaries online all the time, which won't need cleaning as often as the third stage. And then the waste from the primary UF goes into a backwash tank. We're then going through a secondary UF, much smaller skids, and then the filtrate from that goes back to the head of the plant, and therefore it's not needing to be, you're not having the issues with that secondary UF feeding the primary RO with all the controls and everything else, because it's direct feed. We're purely only worrying about the primary UF going straight to primary RO and increasing the recovery overall of the plant by taking that secondary filtrate, which is the majority, 95+% of that waste goes back as filtrate, and a very small amount, less than 1%, coming out as backwash waste for the MF system. So without the break tank, it eliminates a lot of microbial contamination. You're not having to repump the water. You're going straight through the primary RO. So a lot of energy savings there, and it saves in footprint at the plant. So a lot of benefits. And this would be common for any system, but some of the proprietary systems may not lend themselves to the slightly higher pressures that would operate. So I'm going to hand over to Aaron here, who's with me. He's going to just discuss some of our piloting and the open platform associated with that.
Thanks, Richard. Hi, everybody. Hopefully you can hear me okay, and more importantly, understand me. That's why I've only been given the last couple of slides on piloting, but and maybe even some of my Australasian cousins might be logging on from down under as well. So yeah, the last couple of slides we have is on the pilot plants, a little bit of our experience and pointers on pilot plants specifically and what we've found. Obviously, it's very important to run pilot testing for a lot of the reasons Ben alluded to earlier, and running testing with different modules. Obviously, the main key point is we want to run a system or different modules in parallel with the same feed water quality. That's should be pretty obvious, so we can compare our results at the end of the day, and we're comparing apples with apples. So depending on our feed water source and type, that could be a primary factor in deciding what type of UF pilot platform we might employ or offer, or the engineer may decide on, or the client may decide on. And that's dependent on some external factors like the raw water availability and disposal. That can decide what size and type of UF platform we might prefer. For freshwater groundwater systems where it may be required to pilot or may be desired to pilot, we may have limitations on the quantity of water available, and where we put that afterwards, depending on the location. With wastewater, which is wastewater reuse, which is the largest growing market, certainly for us in the US space. We've got an abundance usually of raw water, and we're got a lot of data in terms of the quality testing, diurnal variations, but it's a water that can change its nature quickly, changes over time, and it's certainly something that we want to test. So it's really important that we're testing modules directly in parallel rather than sequential testing of individual modules. The time for testing that may be available for us, we might have a consistent water source and we've got plenty of time to test it. So we can go for a smaller system, pilot system with single modules, and we can repeat testing, swap the module out, run that pilot for another 6 months. We may not have a time limit driving us for completing that testing, because it may be just for future gathering data for a water augmentation project, as opposed to a time limit to meet some sort of regulatory constraints. So we have some options on the size and effectively the quantity of modules that will be running in a pilot in parallel. So Bywater has a couple of identical open platform UFMF pilots that we run side by side. They are complete integral units. They have all the components for the complete operation, backwashing, maintenance, cleaning, or CIP cleaning of the modules, all in a compact skid. And we can run generally up to 5 modules on one of those units, and that system those 5 modules will operate in parallel. The platform and the design of those skids, as Richard and Ben has mentioned previously, those systems are usually designed with those 5 different modules that we run. We're designing to not for the outliers in terms of the modules which will be available, because we want to keep the system compact, and all the equipment that fits on a single pilot skid. There's usually space limitations on where these things going, and we're transporting them all over the country. So we try to keep it as compact as possible. That means selecting and installing and fabricating with equipment that's going to cover the majority of the most likely modules we're going to use. We can't put in infinitely sized pumps and infinitely switchable actuated valves. Our platform provides, especially important in our pilot plants, they provide a very flexible operating system in terms of the controls, the system integration, with a lot of adjustability and flexibility in the operational sequencing, the backwash sequencing, all of the times, the flux rates, order of maintenance, cleanings, etc. So obviously, it's a critical factor for an open platform system to be able to provide that maximum flexibility. So we really try and focus on, which is great fun as engineers, to try and come up with all the possibilities of operation that we might like to test, and have that all available as options or selectable options for the pilot system. Okay, slide. There we go. Internet's a little slow today. Must be a lot of people logging on. Good news. So we have a couple of photos there, just examples, and they look very similar, but they're not. But I think Ben's may have had a couple of photos of something similar as well. We've got a UF on the left, a 3-module pilot plant, and one of our, it's actually got 4 modules installed, but I think that can take 5 modules, the one on the right. The one on the left is operating in a multi-module situation. So where we don't require higher flows for downstream testing, and we just want to individually test different modules side by side, that's the unit we'd recommend. And we can run different flux rates, different cleaning regimes, all within that on the same skid. Whereas on our kind of parallel mode pilot plant on the right, that's designed for where we're running into slightly the demonstration scale size, where we might want to link up with an RO system, RO skid downstream. And generally we like to prefer to pilot test in as close to full scale as possible. So if we're running an 8-inch 2-1 array RO downstream, we're going to need a significant filtrate flow to accommodate testing of that system downstream. So we have a multiple module skid that effectively has the same module in. We would run those in parallel. We'd have 2 of those units in parallel, so we can have 5 modules of one type on one skid, 5 modules of another type we want to compare on the other skid, and those systems will operate in parallel on the same raw water source at the same time, feeding downstream to something like an 8-inch RO membrane system. So all of our systems, just to wrap up, they can all be operated in either a brake tank or a direct coupled RO feed. All of the, that'll be dependent on the module we stick in ultimately, but the skid platforms are set up for it in terms of pressure ratings. They all got the multiple operating modes, really important for pilot testing. So we can test multiple parameters, fluxes, clean modes, and sequences. So yeah, there's not too much more than that. I think Richard is going to put up a special presentation code today. If you want to order one of these, you can get one. If you use the AMTA code today on your screen, you'll get a discount. I think that's what we discussed, right, Richard?
Yeah, sure. All right, well, that's it for our scope of the presentation. Well, thank you, and we'll hand it back to Ben or Denis here.
Richard, don't forget to send that code out, please. Thanks, guys. I appreciate it. Next up, we have Denis Guibert with H2O Innovation. Denis is the Managing Director of the Water Technologies and Services Division at H2O Innovation. He has 25 years of experience in the water industry. His professional experience is ranging from membrane R&D to the design, fabrication, and startup of large-scale UF, RO, and MBR facilities. Thank you, Denis. You're up.
Thank you, Ben. Hello, everybody. So I'm going to share some perspectives on 2 FiberFlex projects. So the FiberFlex is the name of our open platform concept at H2O Innovation, and I'll share some stories on what can happen if you don't have such a system, and what could happen on a more positive framework if you design a plant with an open platform concept. Change the slide. So I'll first start by exploring a concept which I call the Oracle syndrome. And it's more like about philosophy and design and psychology to some extent than pure technical aspects. So, in general terms, predictions are tricky, especially, if you're trying to predict the future. And it's also applies probably more to politics, but in real life as well. Promises that are being made often only commit those who believe in those promises. And if you have a salesperson in front of you that promises you that they will never give up that product line, that they keep making that module for the life of the facility that you're buying, or that the company will always be in business, that because they're such a big company that they'll have the resources to not let the customers down and support the product forever. That same person is not in charge of the product management development cycle in the company, being in sales, is possibly looking for another job as he or she is talking to you. Worse yet, might be fired before the end of the year. And in general terms, is that person is not aware of what's going to be for lunch at the cafeteria next week, but is promising to you that they can predict the future of the drinking water market several years out. So I think in terms of concept, we just have to put this in perspective, and that's the value of the open concept and the open platform system. So there's some holistic advantages to designing for different choices. So a corporate one, I think Ben already talked about this, so I'm not going to expand too much. But today you want to deal with company X, and that company could be bought, could lose its focus, could divest from the water business, could get some new management that is not as good as the old one, and just not be the same company you dealt with like 5 or 10 or 15 years ago. We talked about the technology. The technology you buy today is the one for you. It's the membrane you wanted. It's the best value. You possibly piloted it. You like it. You think it's the one membrane that's the one that's going to perform for you today. But there's likely going to be, there will be actually new, better technology from vendors. Ideally, if you only have a single module system from the same company you bought, but it could be a competitor from that company you bought. So what happens if the technology bandwagon just passes you by and you place your bet on a company that was the best one 15 years ago, but not the one today, right? Mechanical as well. So, the advantage mechanically is that the true engine of your plant is the fiber, right? That's the engine. That's what makes your plant run. That's what controls your cleaning interval. That's the chemistry that controls your facility. The physical aspect of the module, the shell around it, is just an outcome of that, but that shouldn't drive. At the end of the day, that's not the main process performance driver of your facility. There's no good reason why this mechanical aspect should lock a facility if you're an owner or a designer. We talked about warranty as well. We always like for things to happen per plan and just stick to plan A, but sometimes you have to go to plan B or plan C. So what if you have performance issues? How are you going to be able to negotiate if you don't have a choice, right? The leverage that can be applied or negotiated is just non-existent. And the same really applies on the replacement side of things. So the modules that are bought for facilities, the commitment on the pricing is generally, in 99% of the cases, committed and capped or committed for the warranty period of the membrane. So for the first set, right? So you're gonna know how much you're gonna pay for a replacement module for the first generally 10 years. And that's capped or escalated within indices and everything. But at year 10 plus 1 day, it can be a free fall, or in most cases it is actually, and you're at the mercy of the pricing that can be available for you today. And if there's only one membrane that fits in a facility, well, that pricing is whatever, depends on the moon phase or whatever, right? So you don't have any control over that if there's only one module that fits in your facility. In terms of the design, so we talked about this a little bit through the previous slides, but I'll offer a couple other things here. So compared to a proprietary rack, which you have here in the center, I don't know if you can see my mouse, but when you install a UF module, you need a connecting spool on a permeate at the top. That's going to be clear to see, if you have any integrity issues, to look at bubbles if you have broken fibers. So that's a spool that you already need no matter what. You also have to connect your backwash spool to the backwash header. So there's another spool that no matter what you have to include. If you want to lock in the rack mechanically and force it to a single module, then you connect the bottom feed directly into the feed header at the bottom, right? So if you want to make a flexible rack, the secret, which is actually just that it's as simple as this, but you build some flexibility in terms of, you put a degree of freedom on your feed by adding a spool of a few inches that allows you to adjust the height of the module based on the different variations that you have. So you add a coupling and a spool to connect the module at the bottom. Instead of doing it directly from the header to the module, you put a little spool of a few inches in between. So the cost impact of doing this is really a rounding decimal error. When you're looking at a multi-million-dollar system, you're probably going to spend $5,000 on 50 or 100 spools and 100 couplings. So it's really not a cost thing. It's the designing an open concept is very much a philosophical risk management aspect more than a cost thing, as we discussed. And then once the box, which I call the box is the frame, once the membrane rack is designed, then it's a standard design approach that can be applied from project to project to project. So if you've done the effort initially to design a membrane rack that can accommodate several modules, then you don't have to redesign it again. So there's no hidden cost inefficiencies or added engineering or extra costs like this, because it becomes a standard product and you decide to put module 1, module 2, module 3, module 4, but there's no re-engineering to be done on that. So at the end of the day, that's a very simple concept from a design perspective. And the main question is who ultimately benefits from having a mechanically locked MF or UF facility where you can only install one module. If you're a customer, you should ask yourself, am I going to be benefiting from that, or is it going to be the membrane supplier, right? That's really the question we're looking at here. Time for a polling question, Ben.
Okay. Okay. First polling question from Denis. What is the main impact of designing an open platform facility? Is it much higher capital costs, a slight increase in the membrane rack height, or longer design and engineering cycle? Take a moment. Please submit your response. Okay, let's go for it.
Right, so the answer is the slight increase in the rack height. I was saying, like, the design and engineering cycle is the same as suppliers of systems like this. There's no additional engineering to do on this. If somebody wants us to design a rack that is mechanically locked and can accommodate a single module, we can shackle the owner to a single module if he so desires. But doing so, doing a flexible system doesn't add any time in terms of engineering and design once you've done the initial work and set up your system. The capital cost is very insignificantly, impacted. As I was saying, you're talking a couple spools and a few spools and few couplings, and it's insignificant. Next one. It's gonna go. So I said at the beginning of the presentation, I was going to share two stories. So this is the first story, and this is the one where you don't have an open platform concept with, and you suffer the consequences of that. So this is a facility in Texas. This was a 3 MGD facility installed back in 2005, 3 train plants, everything running decently. That plant was built with the Aquasource membranes back in the days. As you can see here, the frames are in aluminum. The piping is in good condition. There's no rust. It's aluminum, so nothing is falling apart. It's rusting to bits. The stainless steel piping is in decent condition. The valves have been maintained. Everything's fine, except there's just no fiber. It just can't get replacement membranes to maintain the integrity. Can't get new modules for the replacement set. There's just no way to get fibers. That module is not manufactured anymore. It's not supported, so customer was stuck having to look at a plan B for that. And the amount of effort essentially is a complete rebuild of the facility. So you have to first start with a piloting, which is not would have been done anyway because this is in Texas. The TCEQ regulatory body there would mandate piloting for new membranes. Even if you had a FiberFlex, you would have had to pilot to test that new membrane there. So the piloting would have been done no matter what. But you have to tear down the whole thing. So you have to write specifications, to issue specifications for new membrane systems. That was done in March 2022. By the time everything was said and done, the plant was finishing commissioning in the spring of 2024. So you're looking at a 2-year process, and you have a complete tear down and removal of the existing facility, which didn't really need to be done if membranes had been available. Obviously, you're not looking at a 5-minute job. You have to tear down everything. Short of a jackhammer, you're using a whole bunch of tools to get this done. Plant was shut down for a month, so you can see there's no trains left to be able to do any kind of work inside. So this took a month of preparation work to be able to get this done. The end result, it's a 2-year process from specification, OEM selection, general contractor selection. Then you have the construction, the permitting changes, and et cetera, et cetera. It's just a 2-year process. The amount of money spent is just magnitude higher than what would have been spent if you were able to do a module change on the universal rack, but that was just not possible here. We did install 3 trains to match the existing facility, but the flow was increased to 3.6 MGD because we had newer modules, so slightly higher surface area. We had better chemistry, better performance, so we're able to provide more surface area. So now that plant here that you're looking at is built with FiberFlex. So the customer got caught once, and he made sure that he would not be caught a second time. So now he's got a plant that's allowing them to be able to install several different modules. And if in 10 years the module we're looking at is not available, he's got ability to put several modules in his facility. Won't get caught a second time. The irony, I would say supreme irony almost, is that the module you're looking at here, the form factor of that white module was actually available back in 2005 when they first built the plant. So that module shape form factor was launched in 2002. In 2002, it was a different fiber. It was not as performant as it is today. So the product has evolved, the product has gone better. But we spent all that money and all that time to install a module that was already on the market back in 2005 when the plant was done. So if the long-term planning had been part of risk management, we would have avoided this whole amount of work and project. The second story, and I'm showing photos because a picture is worth 1,000 words, and the proof is in the pudding in terms of demonstrating that this can be done, and this is a real life situation. It's always nice to say that yes, it's useful. You should design a FiberFlex on open concept, and there's value to it. It's another thing to actually show that customers can really benefit from it, and this is what this second story is about. So this is a plant in Alberta, Canada. It's a half an MGD facility that we installed in 2019. Small plant, nothing special about it. It's got 2 trains. It's a UF&F. There's a UF&F for TOC and THM control, and the plant from day one was built with FiberFlex. The situation back in 2003, all across North America, it was a terrible wildfire season. In the summer of 2023. So the neighboring communities were evacuated, and a lot of people, like fire refugees, were actually displaced into the city that we had our plant at. So there was a big influx of population, and the other drinking water plants in the area were unavailable. We're talking about conventional plants that were unable to absorb the ashes and the changes in feed water quality, and so they had to shut down the other conventional plants. That, and also the staff was evacuated because the community was on fire, so there was just no other water sources in the area. So there was a large influx of population to absorb from that community, resulting in you had like temporary camps, refugees, people in hotels and everything. So the population increased dramatically, leading to a much higher demand. So they needed to address that emergency, but also look at a long-term solution to be able to, bring the resiliency of the community, higher for future seasons, potentially of future fire problems. So the solution was to pack more surface area into the existing trains. So we went from module A, which was 829 square feet, to module B, which was 969. It's interesting to mention that when we designed that plant in 2019, that module of 969 square feet did not exist. So again, we're talking about technology, innovation, and being able to capture that. That module was not launched back then. So, but that became available today when we did this, because there was, we had a FiberFlex system that allowed us to do that. So on top of the surface area pickup, we filled the rack, completely to 20 module installed out of 20 spaces. So that gave us 30% pickup in surface area, and then we used everything left in the pump and the VFDs and the pipe, and we maxed out everything to get as much flow as we could. Then we updated the set point in the PLC. So as was mentioned before, if you design a FiberFlex, or so you design an open platform rack, the code doesn't have to be changed, and you have ability to your sequences are able to adapt really easily to different modules, and you just have to change set points. You don't need to reprogram the facility. Then we installed new pipe spools. So, we're not talking anything proprietary. There's no proprietary fittings and molded parts that you have to buy. We're talking elbows and tees. And then we installed a new module. So between the surface area increase and another 10% left in the pump, and then maxing out everything in there, we got a 40% increase of the plant capacity. And this looks like this in terms of module changeout. So in the photo on the left here, you can see the back train. You have the new modules already installed. And on the train on the front here, the modules are removed, and you can see the old modules being removed on the floor. On the right-hand side here, you have the new modules being installed. You can see in the background here, you still have the old module on the other train. And yes, it fits and it works. So the advantage of this is that we wanted to and needed to do a lot more flow quickly. So the last thing you want to do is shut down the plant for a few months. So we're able to keep always one train in operation at a time, and just work on one train while the other one just carried along. On the left-hand side here, you can see the original module. So you have train 1 running with the old module. You have train 2, running with the new module in the background. Interesting to mention here that this was actually a bit more complicated, or it's another additional complication that you'll hear often as a potential drawback, or why it doesn't work to do open platform, is the port configuration at the top. Some modules have you can see this module on the left here, the permeate comes out the left side, it doesn't come out the top. But the new module, the permeate comes out the top, and the backwash waste comes out the side. And it's often a critic on the open concept that says it doesn't really work, it's complicated, you have to change everything. And here you can see on the photo that if you design your rack properly, there's really no impact, and it can be done very easily. The amount of work was 3 days on site for 2 H2O innovation technicians to be able to do that work. What's interesting to mention is we, as H2O Innovation, we did not have to do this. Other outfits could have done it. And I think it's more in the philosophy aspect of the commercial aspect and the relationship on UFs between consultants, owners, and OEMs is that relationship. If we had not serviced that customer properly and he had been unhappy with our services over the last 5 years, he could have called somebody else and ordered PVC elbows and ordered modules and got it done by somebody else. From a business perspective, we like that threat of having our customers not dealing with us if we don't do a good job for them. Right? And I think as an owner, you probably would like that threat as well, to keep your suppliers honest, and as opposed to being forced into a purchase. So we like that vulnerability as a business, to say that we will only deal with customers and service them, and we'll only get the phone call if we do a good job. We prefer that to a relationship where we know we're going to get the call because nothing else fits. So this is the end result. You know, nothing takes 5 minutes, but it took 4 weeks from the phone call to having the new modules installed and getting a 40% increase in capacity and getting the town out of a a deep problem. In terms of economical efficiency, this would be the lowest dollar per gallon of capacity expansion that you could probably dream of, and we got a long-term solution in record time for the city. Time for a polling question, Ben.
Okay. All right, which benefit would you not get in a typical open platform module changeout? Improved pricing through competition, better permeate quality, potentially higher plant capacity, or a faster schedule? Please submit your answers. Okay, let's go ahead and close the poll and see what we've got.
Right, so there was a bit of a negative in my question as a trap, so I think a few people fell for the trap. Sorry about that. You will get, usually you're going to get better pricing for sure, because you can call several people and say, hey, manufacturer A, I've got a project, what's your price? Manufacturer B, I've got a project, are you interested? The one thing you will not usually get is permeate quality, right? So between the different membrane vendors, permeate quality, you're going to get a typical UF permeate quality 0.05 NTU. You're not going to improve, you're not going to improve your permeate quality by changing module. As we've seen in the example I was highlighting, you're likely to be able to get much higher capacity, or much higher, 10, 15, 20% capacity, either through a new chemistry that's going to be less fouling, or you're going to have more surface area in the new modules, and you will get a faster schedule, right? If you have an open platform and you need to expand your facility, you don't have to start taking the jackhammer or opening the roof or getting a contractor into the building and just change the module. You'll for sure get a much faster schedule. So that's another big advantage of the open platform, is the speed at which you can react and get something done. So closing thoughts. So Ben mentioned that earlier as well. So today, this is a reality. We see about, as a system builder, we see that about 80% of the facilities today are specified with a requirement for flexibility. I would say that you don't want to view a selection for an open platform as an inability to make a choice today, or a weakness that you're not able to make a decision. To the contrary, I would say that you should acknowledge the fact that risk management is a good thing, and that the same way that in your portfolio you're not putting all your eggs in the same basket, that in the design of a membrane facility, risk management is something to be taken into consideration. Also acknowledging that predicting the future is hard, and it's probably some value in hedging your bets and hedging the future by building a system that allows you to do that. Yes, an open platform rack will cost you more. It will cost you a few inches in height. It will just not cost you more dollars, right? As we said, it's just the incremental cost of a few groove mechanical coupling and a few spools that are going to be 4 or 5 inches instead of not being there is just insignificant in terms of the capital cost of a system. As customers, the way we look at this is the fact that if I were a customer of a membrane system and I wanted to buy membranes, I would not want my business to be forced upon me. I would want that business to be earned through good service, good relationship, good performance on the membrane as well. So I think as well, in terms of the project, an open platform concept really de-risks a project it's about the risk management I was talking earlier. Just don't put all your eggs in the same basket. Just like it's just there's a reason it's a nice proverb and people use it. It's common sense almost. Flexibility gives you a choice at better technology, whether you're going to get a new fiber, a higher surface area. Technical obsolescence is there, and that plant will depreciate. But if you have ability to enable and embrace new technology, you're going to protect the value of your assets because it can be upgraded. So there's also an obsolescence piece to that investment that you're making in a brand new facility that should be considered and in protecting the asset that you just built. And thank you for your attention. That's just the end of my presentation, Ben.
All right, thanks a lot, Denis. Appreciate it. Okay, so next up we have Dan Dye from West Tech, but before we get to his presentation, we're running a little bit over on time. I suppose I am to blame for that mostly. Apologize for talking too much, but what else is new? So we can extend a little bit beyond the 2 hours. Want to give Dan time to go through his material, and then still if we try to leave a few minutes for our Q&A at the very end. So if you can stick around, we'll be on for another, say, 15 or so minutes past the 12 o'clock timing that we were supposed to end at. Dan Dye is a seasoned professional with 12 years at West Tech. He's moved up from a project and team management role to product portfolio manager. He specializes in membrane filtration systems with expertise and leadership that define Dan as a driving force in innovation and product development within West Tech and in the industry. So thanks, Dan. You can go ahead.
All right. Thank you, Ben. Thanks for the introduction, and I appreciate everyone sticking around through the last hour and a half here. I'll try to make this brief. So this, the last presentation here is about West Tech's experiences and perspective as an OEM. Let's see if I have control of the slides. Yeah, it looks like it. So the content for my talk, similar to the others, is we'll go through some experiences we've had that have kind of spoken to the need for the open platform concept, just briefly touch on specs, and then our product offerings. So some of the key experiences that have reinforced this concept, I think you've already heard from the speakers, but we'll just show a couple other ones. Module obsolescence and retrofits has been a big one that we've seen a lot happen over the last 20 years. So a little bit of a lag there, my apologies. So here's a couple plants. We have several sites in Oregon State that are approaching the 20-year-old mark. Some of these were actually installed with a polysulfone membrane originally, and then like this system on the right was polysulfone that was retrofit to Torre's UF about 10 years ago. Then we have some that are around that 10-year-old mark that are originally shipped with the Torre HFS module. But if you've been around long enough to install the Torre HFS module, come on, slides. All right. Raise your hand if you've ever had to submit a letter to the Department of Homeland Security saying you won't produce weapons of mass destruction with your module. I recognize I cannot see your hands as you're raising them, and probably not many of you are going to do that. But there was a period in time where when you shipped an HFS module, you actually had to submit that letter to Torre. It was interesting to see how over the years since then, Torre has, of course, evolved. Their fiber has evolved from the HFS to the HFU product to now the HFUG. But simultaneously, they were evolving their module housing to eliminate the need for that risk and the need for having to produce those letters. So over the years, it's been really interesting to see their own product evolve and how that's impacted our customers. Some of these ones that are 10, 12 years old are now replacing the HFS with the HFUG, as Torre likes to say. I mean, it's a nice that Torre's been able to keep it backwards compatible throughout the years, so they bolt right in. and it gives our customers a swell of an upgrade. Just got to kind of tease Ben and team about it for a little bit here, but it's been, you know, with these, so this is like a direct example of even within one manufacturer, one brand, we'll see module obsolescence occur throughout the years, throughout the decades. A much more common retrofit we've seen, though, they're not always that easy. That's a very simple example where you just stay within the brand. Over the last 10 plus years, we've done lots of retrofits where customers have a much more complex system that was designed, you know, fairly heavily optimized for one brand of module. These pictures here are of a system in Texas. Customer wanted to upgrade their system from 8 to 10 MGD. They'd had 2 brands of modules previously, so this was their third set. When we engaged with them on this retrofit, it was their third set of modules. The first 2 were not meeting performance criteria, they couldn't meet capacity, and they had excessive fiber breakage. So we were able to partner with them, do a retrofit, and provide them with new technology that increased their flow rate within the same footprint while leaving expansion capacity within the rack still, reduce fiber breakage, and improve system control and automation. So this just speaks to the need. Like, these systems are, as Denis was saying, if you go back and retrofit these racks, you try to reuse as much of the hardware as possible, but there's still a lot of work that has to be done, a lot of engineering that goes into, you know, where do you reuse and where do you draw the line there at reuse versus just scrapping material and starting fresh with piping and frames and trying to make your system fit. So these retrofits really speak to the need for these open platform systems. Over the last 5 years, it's been really interesting to see how the U.S. markets kind of changed and evolved, and all the supply chain issues. I think Ben touched on this quite a bit. How the PVDF market really struggled in early 2022. Just a few years ago, we had an example where we had 2 UF containers. Customer needed them immediately, wanted them within a couple of weeks. We went to the membrane manufacturer that they were optimized for, and we're told they were 6 months lead time. And it was just an interesting point in time where across the US market, where we were just accustomed to membranes being in stock and inventory or very quick lead times, all of a sudden the market changed and we were looking at 6, like Ben said, maybe even 12-month lead times on markets. So fortunately, because of some of the built-in flexibility in this module rack, we're able to switch to a different brand they had just enough to meet the 3 to 4 week lead time. But that was kind of an eye-opening experience. It kind of new experience, hadn't seen that before in the industry and in the supply chain, and it really spoke to the need for the open platform system as well. Here's another example. This is a very custom engineered open platform system in California. This one was designed to support 6 different module brands. And there was kind of a delay between submittal, the development of our designs, and submittal and approval of the submittal, and then when the contractor was selected and production started, installation started. So there was a 2 to 4 year delay in there. And in that time, it's interesting to see how things changed, where one of the module brands was no longer available on the US market. So fortunately, they hadn't selected that one to be installed at startup, but it was one of the ones that it was specified you had to be compatible with. And that one actually just vanished from the US market in those couple years. Another brand changed ownership, and then another brand released some new product offerings on the market and some more competitive pricing, and that caught our customers' attention. And so we ended up switching from one brand to another even before startup. So, I mean, we think of the benefits of open platform systems for, 10, 15 years down the road when it's time to replace the membrane modules, the new set, and why we want to be competitive at that point. But there's also some things that can really speak to the need, like right up front. Either modules are not available when it comes time to ship the project, or potentially, this should be probably pretty rare, but things might change between engineering and actual startup, and the customer decides to go with a different module for startup. Another thing that's been really crucial to us, and we've worked with a dozen plus different membrane manufacturers over the last 20 years, but like supplier responsiveness and technical support is really crucial to us as an OEM. Another benefit to open platform systems is that they keep us and they keep the module suppliers really engaged and accountable. As you know, companies evolve, key employees may come and go, relationships change. And all of this, the confidence we have in our membrane suppliers is crucial. So our trust in the brand is not only tied to the module's performance or the fiber's performance, but it's also closely tied to the membrane supplier's responsiveness and technical support capabilities. So this is kind of a little bit of a rehash. Ben touched on this quite a bit, but back in the 2000s, it looked like specs were mostly written around an OEM that often had an exclusive module agreement. Specs evolved as more high quality, non-exclusive module brands hit the market. And then in the 2010s, and then currently specs will often have both a section specifying OEMs that can bid and a section specifying qualified modules. And as some of the others have said, we'll also see the specs will dictate the quantity of modules that must fit within the OEM's system. So here's some language. The OEM's rack must accommodate 3 of the 4 approved modules. So it's not often that we'll see, we have seen like, here's 6 that are approved, your rack must fit all 6. But oftentimes it'll be, here's 3 or 4 that are approved, select 2 or 3 that you want to accommodate into your system. And then it's up to us to decide which ones fit best within our rack or which ones we believe will work best for this customer in this particular application. Okay, polling questions. Over to you, Ben.
All right. So ultrafiltration membrane systems perform a pressure decay test, or PDT, with pressurized air on which side of the membrane? Is it on the feed side, the filtrate side, the feed or filtrate side, or depends on the brand? I'll give you a moment to answer that one. Okay, let's go ahead and close it and see what we got.
Great. Okay, that's interesting. So that's interesting. A lot, 30% selected filtrate. It really depends on the brand, and we've seen that even within a brand. We've had manufacturers change from their suggestion from feed to filtrate over the years. So that's kind of they can be correct answers, but of course it's really dependent on the brand. All right, next question. I forgot we stepped them both in here.
All right, this one's a true or false. US modules from various manufacturers fall common dimension, slope, and can be installed. Give me a moment there. Okay, let's go ahead and close it. See what the results are.
Okay, so about 2/3 of us are paying attention here. If it was that easy, if they're like the RO model, then we probably wouldn't be having this webinar, right? There's definitely differences amongst all the different brands, the flow paths, dimensions, and they're not as easy to interchange as RO modules or RO elements. Okay, so just back to the specs a little bit. Considerations for making systems truly an open platform. If we talk universal rack, that kind of implies skid frame, and the skid frame, as we discussed, really isn't sufficient to make a system open platform. We have to consider the flux rate for each brand, how many modules are required, do the modules have the same flow path outside in? Denny talked about the different nozzle connection points, are the materials the same? Can our feed and backwash pumps provide sufficient flow for all brands? Is cross flow required? Can air compressors or blowers deliver sufficient air scour flow rates? Can the chem feed systems provide all the chemical types and concentrations at the desired cleaning flow rates? Can the pipes handle the velocities? We see some pretty big differences in the backwash flow rates from one brand to another. And so sometimes that actually, if you're trying to accommodate all brands, you have to actually increase, for example, your backwash supply and backwash waste piping area to accommodate higher flow rates. And then can the control system accommodate multiple brands? That's been touched on a couple times here as well. So all of these experiences and what we've seen over the years as the specifications evolved have kind of driven us to look at our own internal product development goals. So our goals years ago is start creating systems to accommodate 10 plus module types. So of course we've looked at some of the big ones as well as, you know, a variety of others, but Toray, DuPont, Hydronautics, Sinor, Asahi, Nanostone. Protect against, you know, our own goals were to protect against product and technical obsolescence, minimize the risk of future retrofits, and offer competitive environment on membrane replacement costs. Some of our system requirements then are incremental flexibility without added cost, minimizing footprint and height, considering system aesthetic qualities as well as serviceability, customizing for project-specific instrumentation and footprint. You're still going to see, even though we standardize our designs, engineers will still, or customers will still have a preference for project-specific instrumentation, or they'll have some tight footprint requirements that we have to be able to accommodate. And of course, we want these open platform systems to be able to work with both high and low flow applications. With the, just touching on controls a little bit, as I think a couple of people have already mentioned this, so we'll go through it fast, but our controls have also evolved over the years. These aren't often specified as closely as the hardware is, but our controls have definitely evolved to be able to accommodate all the module intrinsic properties like surface area, flux, pressure limits, module operational differences, like differences in backwash and cleaning integrity sequences. And then we've also evolved our controls to allow for easier updating or sequence changing during commissioning or when we change from one brand to the next. So there's less hard-coded PLC logic, more intuitive interfaces, which allow our commissioning team, customer engineers to update the system in the field as easily as possible. So that just means bringing out a lot of the parameters that may have in the past, like module surface area may have been just hidden in the PLC code 10 years ago. It's now right on the front, so people can change that as needed. And then we have our sequencing setup, so that allows us to do things like change the backwash sequence steps and which valves are open, which valves are closed, which pumps are on. We don't need PLC programmers any longer to make these fine-tuning sequence steps as we change from brand to brand. We're able to do that just at the user interface there. So it just speeds up that recommissioning time if you have to change from one brand to the next. So our Versa, as Ben said, like our Versa filter system was installed or first introduced around 2015. We had one go to a municipal customer in Kansas and one to a mine site in Nevada. Since then, we've done dozens of these, and this is our most recent example. This is a 30 MGD system sold in 2024. That's just taken, there's been, you can't see it by looking at it, but there's a ton of lessons learned and engineering principles that have gone into the design of this system, and a decade of these lessons learned have been integrated into our product offering now. So just a couple parting thoughts, and we'll turn it back to Ben. These membrane systems form really long-term relationships with our customers. We have some that we've commissioned. I personally commissioned some 10, 12 years ago that I still keep in touch with the owners on a personal level. And then, of course, our aftermarket support and customer service teams keep in touch with projects that date back to 2002. We just have some membrane systems that have been around for a long time, and all of these projects form these long-term relationships. So by embracing the open platform concept, it really protects both our customers and ourselves and helps prepare us all for these future market evolutions. So, Ben, it's back to you.
All right, thanks, Dan. That was swell. All right, so we are into the Q&A portion, and like I said, we can hang around for a little longer. Let's give this maybe 10 or so minutes to try to go through some questions. I will say that I had some technical difficulties logging in today. Murphy's Law, I suppose, but so I am looking at someone else's screen, so we'll try to do our best with this Q&A, and hopefully I'll be able to look at some of these questions here. Okay, so the first one that I see, this one looks like it's for Richard and Aaron. It says the picture bywater supply to the U.S. system at the arc grip showed UF membranes fairly high off the ground. How are the UF membranes removed for repairs?
Yeah, that's a great question. Great question. We have carts that ratchet up, and you can you can stand on the skid frames when you're up there, and then you strap them into the loading rack, and then it ratchets down to lower ground and can be put on carts and rolled around. So it's not too bad. It has to be high up because we got piping and flow meters underneath the skid, because the desire was to send the systems assembled as much as possible.
Okay. Next question. It says, the presentations do not discuss the issues related to controls differences, backwash, and cleaning flow differences, or the possibility of a future replacement provider of the membrane might feel the flux and recovery of the original design is too aggressive. How are you managing these deviations or complications? So I suppose some of these issues were covered, especially in Dan's presentation, with relation to setting up the control system to handle such differences. Since I referenced you, Dan, I'll pass that to you. Do you like to add anything to?
I think we touched on some of that over the years. Most specifications don't address what is required of the controls. We've come across one or two fairly unique specs over the years that dictate that. One of them had us demonstrate that we could commission the PLC sequences for all 6 brands of the modules supplied. But that's kind of rare. But still, in the background, we understand that the issue you're referring to there is, DuPont and Toray, while they're similar, they have differences and nuances in their sequence of the backwash or the chemical cleaning sequences, differences in the sequence steps, as well as the flow rates, the air scour flow rates, the cleaning chemicals. Some require 4 chemical types, some only require 2 generally. And so we do have to account for all of those differences when we're designing our system. And so that often, enters into conversations with the customer and engineer. If it's not crystal clear in the specifications what the intent for the degree of open platform design is, we'll have to ask those questions and say, okay, how much flexibility do you want? Do you truly want to be able to accommodate all 6 of these brands with all 6, with hardware installed up front for all of their different cleaning chemicals and backwash velocities, or do you want to just optimize for 2 or 3 now with the ability to add additional equipment later if you need to change the process equipment? So we definitely have to take that into consideration up front. It is a big factor. That's, like I said, it's more than just the rack. There's a lot of other supporting equipment in the plant that is taken into consideration.
Okay, great, thank you. Okay, next question is the market moving away from submerged UF in favor of pressurized UF? Denis, you haven't answered one yet. You want to take that one? Okay. Denis, are you there? Okay, I'll go ahead then. Can you hear me? Just make sure. Okay, great. Okay, so in short answer is yes. The market has moved away from submerged to pressurized UF membranes. In a nutshell, the submerged UF membranes were originally thought of to, well, let's just say that submerged is good when you're talking about very large systems. So there are some economies of scale that can benefit submerged UF systems. And when you think about building a small tank for those membranes versus a large tank, the bigger you go, the more cost effective it becomes. Originally, it was also thought that pressurized UF membranes were not suitable for handling higher loads of suspended solids. There's still some truth to that argument, but we've learned that pressurized UF does have much more capability for handling higher TSS or higher turbidities than before. So those are a couple reasons that it's moved more towards pressurized and away from submerged. That is, that pressurized can handle higher solid feeds and is easier to manage. They're more modular system. It's easier to add a rack inside of a building than it is to put in to build another tank and so on. So yes, the market has moved that way. Okay. Next question is, did you use Pentair UF membranes in the US? I suppose I can take that one as well, that Pentair has been used in limited capacity in the US. So there are some, but not so much. Okay. So last question here. This is a good one. Maybe we'll have both Bywater and Westech give your thoughts on this. So this one is, are any manufacturers trying to create products that meet Buy America, Build America requirements? So you guys, can you speak to that from the system point of view? And if there's time, I'll make some comments with regard to the modules.
Sure. Yeah, I'll answer first, then they can go. I think we've seen, certainly are putting a lot of effort into figuring out how we can be compliant with that. It's interesting to see the membrane modules themselves on smaller systems. The cost there isn't too much of a factor, so we're likely to be able to be compliant more easily on small systems. When you get to these larger plants, these 30 MGD, 50 MGD plants, the module cost becomes significantly a significant portion of the system cost. And so the actual module manufacturers themselves are going to have a big part in whether we can be fully compliant as a OEM. And so kind of turning the question back to you, Ben, I mean, we've heard some rumors throughout the market that there may be some shifts going that way, but it's probably not something you can answer right now. But I haven't seen any single manufacturer yet state that they're going to be able to provide a BABA compliant module. So it might just be taking that exemption, at least for the near term.
Mm-hmm. Yeah, what I would say is that at the moment, there are no large-scale UFMF hollow fiber manufacturers in the United States. And so in order to make that happen, we would be considering a very significant investment. And even after making that investment, there is a question of whether or not the product that we can make in the United States would be cost competitive enough. It would definitely be more expensive to do it in the States. And so there's I think that there are some exceptions that can be taken to the BABA regulations in the case that the only product available in the United States is X percentage more expensive than one that is not made in the United States. And so let's say that Toray decides to build a factory in the US, but the product that we wind up making is 50% more expensive than one that can be imported. Well, number one, there's an exemption that those external suppliers may be able to take, and then if that exemption doesn't exist, then we would experience that 50% increase in cost. And I'm throwing around 50% just as a number to consider, okay? And so eventually, people have to pay for that, right? So that will certainly have an impact on the overall system cost. I would also say that these sorts of regulations are heavily influenced by the government and who's making these policies, and we know that can swing from one direction to another direction, and so in the course of a 4-year term, that's not nearly enough time to build a factory and make that huge investment, and then potentially see it get the policy be completely reversed after that period. So I think that the manufacturers are in a tricky spot now, and I think we'll see how these regulations move in the future as they become hopefully solidified one way or another, and once we know what the longer term outlook is, then we can react accordingly. So I think that was actually the last question, and we did hit that 12:15 mark. So I think we'll go ahead and wrap it up. I want to thank our panel members again, Richard, Aaron, Denis, and Dan. Thank you guys so much. Great job, all of you. The perspective that you brought to the discussion was wonderful. Highlighted a lot of things that I had not considered myself. Hopefully it was beneficial for everyone that joined in today. Thank you as well to everyone who logged in. We really appreciate your time, and we would be more than happy to answer any questions that you would have after this presentation. You're welcome to reach out to any of us. Lastly, I'll just say that we have a part 2 of the AMTA Torre webinar series on November 13th at 1 p.m. Eastern, and registration will be open in the fall. And in a moment, there will be a survey displayed. We'd appreciate your feedback on that so that we can get better next time. And on behalf of the AMTA and Torre Membrane USA, thank you all. Enjoy the rest of your day.